Hello there. So this is Julia Schneider, and I'm doing my first video correction for Survey of Calculus Math 130. My first video is on learning target L4, which states I can determine the points at which a function is and is not continuous and can use continuity to evaluate the limits. So this is very, very simple. Let's get into it. So, question number 6. Given the graph f of x, determine all x values at which the function is not continuous. For each value, state which condition of continuity it fails. So, like why it fails. So, I'm first going to explain the correct answers, and then I'm going to explain what I said wrong, and yeah, let's get into it. So the first point at which f of x is not continuous is at x equals -3, which is right here. I don't want to cover these words in case you're reading them, but as we can see from the left and the right, as f of x approaches, the 2 feet will never meet since they're going towards infinity. And because of this, because the 2 feet never meet, it is not continuous. So the next point at which it's not continuous is at x equals 2, which is right here. We can see that there is a function jump. It is as clear as day. I explained more about it here. The function is not continuous due to this jump, but the function is still defined. So f of 2 is still defined, but the function itself is not continuous. And then the next point at which the function is not continuous is at x equals 6, which is right here. We can see as clear as day. I did label that there is a hole. So this is why it is not continuous. And here are the proofs for this one and this one. So as we can see here, if the limit as x approaches, f of x from the right and from the left are the same as the, actual value, then it is continuous. But since they are not, it is not. And this just puts into mathematical notation what I'm saying here and here. So now to get into what I said that was wrong. Up here I said both functions, and that is not necessarily correct language. It's not super important, but it is to demonstrate my understanding that this is just f of x. So there is, one function. I just got confused with continuity, and yeah. So at x equals 2, there is a corner, at x equals -2, there is a corner here, and originally I had said at x equals -2, there's a corner, so it's not continuous. That is not true, because you don't have to lift your finger or do any sort of weird jump with your pen like you do here. It is continuous, the function. It's just not differentiable, and I had gotten confused because the corner means that the function is not differentiable and is one of the grounds for it not being differentiable, and I just got confused. And yeah, so that is my video. I really understand this. I mean, it's pretty clear. You know what I'm saying? And then I'll explain this. I said at x equals 6, it's not included in the function, and I just explained that it is. There's just a hole in the function, so it's so it's not continuous. Not just because f of 6 is not included in the function. It's not, but at x equals 6, there is a point. So, yeah. That is my video, and I hope that it demonstrates a full, great understanding And yeah, thank you so much for watching.